this video is section 3.2, and we're talking about angles of a triangle. Basically, we just got some very simple terminologies, and we'll try to do it. Interior angle of a triangle are the angles inside the polygon, okay? So interior angles are angles inside a polygon. In this case, it's the angles inside the triangle. So here, here, and here, okay? Nothing really hard on that. Exterior angles are when I draw a line. So this was my main side and I kind of extended it out, and then this was my side and I extended it out. When I do so, it creates some exterior angles. So there's an exterior angle here, there's one here, then I've got another one here, and so forth, so on. So this thing has an additional 9 exterior angles around the outside if I draw it out. All right. There's 2 big rules. One, you should know probably since you were just a little fella, is the sum of the interior angles of a triangle is 180 degrees. Meaning if I take all the angles up here in this triangle, whatever they might be, in this case it should be 60, 60, and 60. I add those 3 numbers out, I am going to get 180 degrees. This is a rule that you should know, and I'm going to beat this one for a little bit. This is a rule that you should know. I'm going to say it again. All the interior angles, when added up for a triangle, is 180 degrees. This is something you definitely need to know. All right, the last little piece is something... it's a long one, but it's going to save you a lot of headache in the long run if you can memorize this. This is another one of those rules that there's no way of getting around it. And it says this: the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 non-adjacent interior angles. So here I have is a triangle. I need to know what Z is. Well, this is all I have to do. The angles on the opposite side, not this angle, but the interior angles on the opposite of it, these 2 right here, when I add them together, I get Z. That's all it's saying. So if I know what these 2 are, I know what the exterior angle is. And that's it, okay? So how does this help us? Well, let's go ahead and do a couple of problems. We'll do some easy peasy problems right now. First off, right here. Number 1, it's asking us to find X. Well, we stated a rule that all the interior angles of a triangle should add up to 180. So all I need to do is say 180. I'm going to subtract what I know, which is 32, and then I'm going to subtract 90. I know these things. So I can say 180 minus 90 minus, what was that, 32? And I get 58. So X is equal to 58 degrees. That's pretty straightforward. All right. You can do 2 on your own. That's nothing really difficult. I'll let you do that on your own. But let's look at 3 together real fast, and let's talk about that one. This one says, I know I have an angle of 50 degrees, but then I have this. So what's happening here? It's saying that both of these angles are literally the same thing. So we can kind of write this, we can do this 2 ways, but let's just, for the sake of argument, let's actually use an equation. I know that there are 180 degrees in a triangle, and I know that I have a 50 here plus an X plus an X. That's what I know for a fact. And I can rewrite this again to say 180 is equal to 50 plus 2x. Hey, this looks like familiar territory, so I can solve for x using SADMEP by subtracting 50 on both sides, and I get 130 is equal to 2x. And since I'm trying to find x, I can divide by 2 on both sides, and I get, well, that 130 divided by 2 is 65. So that angle here is 65 degrees. Now, we can prove this another way by just simply doing it in our calculator. We could say, hey, 180, take away 50, and I know that these two are the same thing, divide by 2. Hey, I just did that same method. We can prove that this 65 works by saying 65 plus this 65 plus that 50 should give me 180, and it does. And that's pretty much it for that one. So, why don't you try 2 and 4 on your own and see how you do. What you should have got for 2 was that x is equal to 26 degrees, and for number 4, you should have got x is equal to 32.5 degrees. All right, now, next one. Find the measures of the exterior angle. All right, so this goes with that long-winded rule I told you a while ago, and I'm going to kind of show it to you. It says the measure of the exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. What that is saying is this. If I take this angle and I add them together, I've got x. So 40 plus this, which you should know to be 90, 40 plus 90 is 130 degrees, so x is equal to 130 degrees. I'm done. That's all we have to do. Now we can do this, prove this with another method, but I'm not right at the moment because for the sake of this video, just know this. If you're trying to find that, add the two opposites and you're good. And it's the same thing with this next one. 88 plus 47 gives me 135, and I'm done. So x is equal to 135 degrees. That's all there is to it. Now, I'm going to leave number 7 to you, but I am going to go over a little bit more complicated problems using the exterior angle, because this is where a lot of people get really, really scared when all of a sudden their numbers have letters. And so what is going on here? So it says find the measure of the exterior angle. So we're trying to figure out what this even is. And we have a variable here and we have all this stuff. So before you freak out, go over your rules. It states that this exterior angle is equal to the sum of the two non-adjacents. So that's equal to the sum of 80 plus a minus 5. All right, this still looks scary, doesn't it? Well, let's simplify our life a little bit. We can say that 2a is equal to 80, and we can use, we know that there's like a hidden 1 here. We can use what's the distributive property to get rid of this parentheses, plus a minus 5, because we're using that distributive property. Now let's continue to simplify this side. So we have 2a is equal to 80, nope, not 80, but 75, because 80 minus 5 is 75 plus a. Now, we've got both sides simplified as far as we can do, so our job is to get the variable to one side. So let's subtract a from both sides. When I do, that really is going to become an a is equal to 75. So we found out that a is 75. However, we have a problem. That's not what the question asked us for. It asked us to find the measure of the exterior angle. We only know what a is. We don't know what this is. Well, this is pretty straightforward. We plug a in the place, 75 in the place of a. So when we do, 2 times 75 is equal to 150. So this measurement right here is at 150 degrees. Let's do the next one together. Find the measure of the exterior angle. So again, we know that this 4n minus 20 is equal to this n plus 2n plus 20. These two are going to be the same as that. Let's go ahead and put things together and simplify our sides. 4n minus 20 is equal to n plus, and since we know there's an invisible 1 here, we can use a distributive property. That would be 2n, and then we put another one here, plus 20. Let's combine some like terms on this side to simplify, and we get 3n plus 20. All right, so far so good. Now that we've done that, let's go ahead and get our variables to one side. I'm going to subtract 3n from both sides to get the variables on one side, and that would give me n minus 20 is equal to 20. Now I'm still trying to get n by itself, so I've got to use our SATMEP by adding 20 to both sides. And when I do, that cancels out here, and I get n is equal to 40. Now that I know what n is, am I done? No, because it asked me to find the measure of the exterior angle. So what am I going to do? I'm going to plug 40 back into this expression right here. So I'm going to say 4 times 40 minus 20. Well, that's 160 minus 20. And that gives me 140. So this angle measurement right here is 140 degrees. All right, and this one right, these two right here tend to be the most challenging because it is getting into some algebra and some solving for a variable. So please, when you get to these, let me know if you're getting any problems. And as always, ask questions, and I'll see you in the next video. Bye-bye.